Okay, we're on exponential functions. This is the basic version. Really? Does anybody know what an exponential function graph looks like? Nobody? I bet you've seen them before. Does that look familiar? Okay, time to lock in. We are still in school.
In a way. That AP lit class covered.
So there's exponential growth. You guys have seen population graphs? Okay, it took thousands of years for our world to reach 2 billion people in 1900. How many do we have now? Like 7 or 8 billion. It'll only take 100 more years to get 5 more. So that's exponential growth. It just keeps accelerating. What's really interesting about our population is you might actually start to see a decline. The industrialized countries, the birth rate has actually fallen below the death rate. Most married couples are having less than 2 kids for each of them. So the balance point's like 2 or 2.2 kids per couple to balance the death rate. So that's actually below the death rate. People are having less kids.
Yeah, I mean, a lot of people are married to their jobs.
Yeah, well, some of us have that problem. Okay, this is exponential decay. You guys study carbon-14 dating at all?
It was created.
That's right. I remember hearing that. Well, if you decrease the amount by half, and that amount by half, and that amount by half, you get the decay curve. It never reaches 0 because it's a half of what's left, and a half, and a half, and a half. Right? So it never reaches 0, the x-axis. But it gets smaller and smaller. What happens as x approaches infinity on this one? What does y approach? Oh. Nope. Does it go up or down? So if I'm going this direction, what is it getting closer to? What y value is this? So y approaches 0. So this is the next level of describing end behavior. In pre-calculus or calculus, we would say the limit of as x approaches 0 or x approaches infinity is 0. So it never touches it.
Is that infinity or 0?
It's infinity. But this one over here, you should be able to describe as x approaches infinity what happens.
Negative.
What does the y do? As x approaches infinity, y does, what's that called?
Positive.
Right. Okay, so end behavior. Just okay, this is the model, the form that you're going to see exponentials in. Okay, if you put it in letters, that's what you're going to see. Yeah, the x is in the exponent. That's why we call it an exponential, right? As always, we're just going to do a table of values. All right, so we've graphed. You can graph anything with the table of values as long as you can calculate the answer. So if I plug 2 in, what do I get for my y value? Do I need to start picking popsicle sticks?
You'll get 16. Negative 2. Oh, crap, I did the opposite of us.
Marissa, say that louder. 18. Because it's 3 squared. First, it's order of operations, 9 times 2.
Oh, I know negative 2 is going to be 8.
No, it's not.
8, negative 8.
No, it's not.
Are you sure?
Nope, pretty sure.
Okay.
What's 1? 6, 0. This is where you have to, no,
2.
it's not. Why is it 2?
Anything to the 0 power is 1.
Anything to the 0 power is 1.
No day.
Remember that property? Remember that property times 2. So we got 2. Okay, what's the property for negative exponents? What do you remember about negative exponents?
Ignore the negative.
You can't just ignore negatives.
Imaginary.
Oh, man.
Oh.
Remember, negative makes it a fraction. Drops it down. Remember, negatives put you down. Oh, sad. Yes, another one of our corny sayings. So what's the answer here? 2/3. Okay, and what's negative 2 going to be? Candy bar to the first person?
One half.
You're guessing.
Dang it.
I want legitimate mathematical
If it's
answers.
right.
No.
6/3.
Wrong again.
What?
Do I get to eat the candy bar?
Wait, no. It's going to be 1 over 3 to the second power, right? So it'll be 1/9.
Okay.
2 times by 2
Yeah.
is 1/9. I said you got it.
It's 2/9.
Oh, I got it. Oh.
So it's 1 over 3 squared, which is
1/9.
1/9 times 2 is 2/9.
Candy bar, what would you like? Micro min. It's all 1 pound.
All right, so go ahead and graph it. Don't react like that, Travis. Are you having a rough day? I'm sorry. Oh, is it the 5th day you've gone to school in a row? Must be so difficult.
Yeah, actually, it's so hard. It's so hard. It's going to be worse next.
This is why they school me screwing me.
My schedule is so screwed up. I have literally thought it was on Saturday like 5 times today. I was like, oh yeah. Oh wait, why would I
I
be
keep thinking I'm in trouble because I'm here on Saturday.
Yesterday should have been Friday.
Might make me come. Yeah.
There's our graph.
3 over 2 over.
See how it follows that exponential model. Okay. Because we have negative x values. What's the y-intercept? It is 2. But what I want you to notice is, for now, on the basic version, that number is your y-intercept. Okay? If we start adding things like a constant and dividing by another number, it changes a little bit. But for now, that's pretty straightforward. Right. Are we good? You can graph it. The hardest part is knowing your properties of powers.
I had a bunch of like.
Okay. Part of exponentials. So I'm just giving you the basics of graphing, solving equations. All right. So solving equations, basic. Anybody have any idea how I might solve this one?
Give someone $10.
Okay, that would be one cheating method. Thank you, Miklo, for that.
Google it. Google the answer.
Okay, so check it out. If the bases are the same, what do you have to know about the exponents? Same. Same. So you can set them equal to each other because these two are the same, so we need the exponents to be the same. Right? So you can just plop it down, and now you can solve it, right?
Yeah.
Solve for x, it's linear. Go. Never thought I'd hear that in math class, but rock on. Hear that all the time. Let me know if you disagree.
-3. Oh.
Now divide by -3, you get a positive, right? All right. Does that make sense? Okay, can I solve? I can solve this. Can you?
Oh, no. They're not matching.
You guys don't know how to solve that. So because these are not the same, you can't solve it with current technique. The solution exists, yes, but you don't know how to find it. So you can always graph it, but that would be your more straightforward method would be to graph it. But
Wait, only we can't solve it, or like nobody can?
you guys just don't have the knowledge base.
Oh, that's what we do.
But you can do something like this.
Solve this, sorry.
Well, let me back up.
I can put that on my test. Sorry, I don't have the knowledge to solve this. Yeah, that's what the difference.
That one we can solve. Yep.
Yeah, it says
Oh, 'cause they're
5
solving.
is,
3 and 27 go into each other. That's why.
Is 27?
you just do 9. Divide by 3.
You can't just divide by 9.
3 times 3 is 9 times 3.
Nope.
27 times 3.
These exponents prevent you from doing anything to the base besides making it an exponent.
Yeah,
Can you make 27 a power of 3?
Yeah.
What is it? 3 to the what power is 27? 3 times 3 times 3 is 27. So that's how you have to manipulate this one.
I thought the first one was K.
Now you set the
Is that a K?
two sides equal to each other.
Wait, why did it next?
3 to the third power.
No, you made it next.
3 times 3 times 3 is 9 times 3 is
It was just K though.
27. It's
That's a K.
Huh?
That's K.
That's an X.
Looks like a K on top.
I know, I can tell my letters. But why did it change from K to X?
Travis has not been in my math class for 2 years anymore.
God.
Now, set the exponents equal to each other, right?
Yeah.
Solve for x. It's 20 over 3?
Oh.
Yeah, it's 20 over 3. What?
Right there.
No, what's the next one?
The top was the king.
You're not gonna win.
Thanks.
Thanks to lose.
He doesn't know what he's talking about.
I thought it was the king.
Okay.
Yeah.
All right, so basic graphing, solving, and then I'm going to have you write an equation or two, and we'll be done.
We're done. We're done.
Oh, we're done.
This is stats.
What?
This is stats.
Great.
This is definitely trig. You might run into it in stats. I don't know. I haven't taken
Okay.
that course. Okay. Let's say in 1981, yeah, good year. How many bunny rabbits were there in Colorado?
5 million.
5 million, huh? You just
No,
made
no, that's a little too big.
There were 5. There were 5 rabbits.
There was a stream out in front of me.
Okay, in
1999.
1999, good year. How many bunny rabbits were there in Colorado?
2.
There's more than that.
3 million.
Woo!
So we're going with exponential decay, right? It's going down.
Yeah, they're good.
Remember the first time I shot a squirrel?
First time I shot her out. Oh my
Never
god.
eat
No.
Good.
Grandma mixed up too.
Lots of grouse. Grouse and ptarmigan were pretty plentiful in Alaska. Okay, so the question is, how can I find A and B? So A is our initial value. What was our initial?
5 million.
Okay. And to find B, do we know an X and a Y that we can plug in? If this is year 0,
Yeah.
this is what year?
7.
18.
18 and 10, right? 10 bunnies. There's an X and a Y. 18 is X. 10 equals 5 million. B to the 18. And we have to solve that.
First, you subtract 5 million.
No.
Why? Divide 5 million.
You divide because they are multiplied together. They're inverses. What's 10 divided by 5 million? A really small decimal. Yeah, got that. Thanks.
It's like 0.
It's like 0, but it's not 0. So anybody? Anybody?
You're like 2. Where's my calculator? 0.00.
You're close.
0.00.
Probably a lot more zeros than that.
0.2.
2e to the negative 6.
Yeah.
So that means take 2 and go 6 to the left. There's 5 zeros in front of it. All right, now how do I get rid of the 18th power?
You have to do the 18.
Say it. Yes, the 18th root. Remember, get rid of a squared with a square root, so we get rid of an 18th with an 18th root. So that's a calculator problem.
Man, these buddies are crazy.
Hey, you guys made it up.
Those rednecks went ham.
Yes, they did.
Calm down, okay? That's a lot of bullets.
That's a lot of.
Now you can do that because all the government.
Okay, on your calculators.
You can hardly buy planes. So their stock and stuff are gone.
Oh, my phone does.
Okay, your calculator, you have to hit 18,
Okay.
Go into the math menu.
Yeah, you know about that.
Down to X root. Enter. And then type in 0.00002.
0.4244582701.
0.42 what?
44.
Uh-huh.
That's what I heard too.
8.
That's good enough.
What is it? You're bumping out.
No.
How do you do it?
You go 18.
Hit 18.
Oh, in.
Math, X root.
Oh, five. Ah!
So what's our model?
18. Finish.
Y equals 5 million. 0.42448 to the X.
0.48.
Boom!
What do you do when you study?
Yeah, those rednecks went ham
I'm serious.
on that.
On the computer.
Any questions?
I got
Wait, how did you get the
4.8.
5 million on the second? Or was this the original?
Remember the original
Oh,
A value. It's still the same. Okay, why? So I want you to notice something here. This bunny population decayed exponentially, right?
yeah.
The B value.
So you do that. Wait,
Would you like to explain this? Okay, then. For exponential decay, B is less than 1. So that'll make it curve down. What is B greater than for exponential growth? It's bigger than 1.
B.
Okay.
It is very easy. You got about 10 minutes, you should be able to get through most of it. You just want to start out.
You have, I just told you number 1. 2 should be really easy. 3 is graphing, matching functions to graphs. 6 and 7 are graphing. 16 solve. 17 solve. You do need to write it down as an answer. Why? Because you might want to earn your content grade.
But you just want